marks out of 6. Zero marks. And I guess you got 2 marks out of 4 here. So let's find out why. So question number 13. So 4 identical resistors, A, B, C, and D, are placed in a circuit as shown. Determine the power dissipated in each of the resistors. The resistance of each resistor is 2 ohms. Okay. Okay. So I see you've written quite a lot of values here. And I think you wrongly tried to calculate the total resistor combination. Okay. So point number 1. Point number 1 is, so do you remember, in fact, let me draw it. Let me draw A like this. And then we've got B like this, C like this, and D like this. Okay. So what you could do is that you could do it in 3 steps. So step number 1 is finding out what these 2 resistors are equivalent to. Yeah. Because so anytime I do something dashed, I'm squashing it into 1. Yeah. So this is a series resistor combination. The next step is finding out what this parallel combination is equal to as 1 resistor. Now that you have 1 resistor here and 1 resistor there, you can now just do a quick parallel combination. The last step is to find out what everything is then equal to as 1 resistor. So this is your total circuit resistance. So now that we've got the total circuit resistance and we've got the total voltage, we can work out what the total current is. So IT equals VT over RT. So 10 divided by 10 over 3. And that should equal 3 amps. Yep. What did you get? You got 5 amps.
Because I think, I guess I thought that like resistance of each resistor equals 2 ohms. I thought that it meant that like the total resistance is 2 ohms. I don't know.
Right. Okay.
I can't exactly remember, but since I did that calculation, then that's likely what I thought.
Okay. Now we can work out the power dissipated in each of the resistors. With A, so if we say just PA, the power dissipated in A, we can simply use I squared R. And that's just 9 times 2, which is 18 watts. Okay, right?
Mm-hmm.
Now, the problem comes in this junction here. But it's easy because if you know that there is more resistance in the top path than the lower path, you automatically know that more current is going to flow there. Yeah. Kirchhoff's first law, basically current conservation, can be as simple as finding the ratio of the resistances and doing the opposite with the current. So if you know that this top path is worth 4 ohms and this bottom path is worth 2 ohms, then the total quote unquote resistance is 6. The top path represents, what is it again? 2/3. The top path represents 2/3 of the total. I keep putting quotation mark because the total resistance of this thing is not 6 ohms. I'm just doing a ratio of, I'm just comparing the resistances. That's what I'm doing. I'm not saying that the total resistance is 6 ohms. It's not 6 ohms. I'm just doing a ratio. in terms of ratios, the total resistance of all of them together is 6 ohms. And BC represents 2/3 of those 6 ohms, and D represents 1/3 of those 6 ohms. So the current, 2/3 of the current is going to travel to the least resistance. 2/3 of the current is going to travel to D because it's easier, and 1/3 is going to travel through BC because it's harder.
Okay.
So power dissipation across B is going to be I squared R, which is just 2 watts. So 1 times 2 equals 2. Same thing with C. So I squared R, once again, so 1 times 2, and it's 2 watts. Now the power dissipation across D is going to be I squared R, which is 4, 2 squared, multiplied by 2, and that's going to be 8 watts. So we've got, and we can check our answer by working out, the total power dissipation across a circuit of 3.3 ohms. So P total is going to be 3 squared multiplied by 3.33 recurring, which is about 30 or something.
Yeah, it's like 28, I guess.
29.99. So I'm just going to round it up to 30. And we actually do get 30 right here. So 18 plus 2, that's 20. Plus 2 again, that's 22. Plus 8, 30. Mm-hmm. So it works out. So we've checked our answer. Okay. Any questions?
No, it's pretty clear.
Okay. Bear in mind what I wrote in red here. What I want to it's mathematically correct. It's just that I don't want you to think that this 6 ohms. I don't want you to ever get confused that this 6 ohms is the total resistance of this combination. It's not. It's the total, like in terms of ratio. If I'm comparing the number of parts. So you've done ratios before. You do ratios. Yeah. So that's what I mean by the total number of parts adds up to 6 ohms. That's what I mean. Mm-hmm. Okay, cool. Part B and C. Let me put this over there just so that you recognize that it's all in one. Explain without further calculation what would happen to the power dissipated by resistor A if resistor D were disconnected from the circuit. Our total circuit resistance would increase because now we got 3 resistors in series.
Yeah, so it would be like 6 ohms.
Sorry?
Yeah, so I think it would be 6 ohms, right?
Yeah, so the total circuit resistance would be 6 ohms. And if the total circuit resistance is 6 ohms, then, so let me write, maybe we have to do some calculation because I can't really focus just by trying to look at this and guessing. It feels like we're guessing. So let's just calculate. So RT is now 6 ohms due to 3 series. So therefore IT equals 10 over 6, which is divide everything by 2, so 5 over 3. What is that? 1.67 or something?
So
yeah, 1.67.
1.66 or 1.67.
So the total circuit current decreases. So therefore, the power dissipation across A is 1.67 times 2 equals 5 0.55 watts. Is it bigger or smaller? It's a lot smaller. So it gets smaller. Because circuit resistance would increase. So smaller current. And then maybe you write I squared R just to prove to them if I've got a smaller current, then the power dissipated across A is obviously going to be smaller.